Yeah, thank you for your patience. I love Linux, but when it comes to connecting to projectors, it always has some problems. Hello, all you hackers out there, and all you wanna-be hackers, and all you don't wanna-be hackers. My name is Adrian Furtuna. I'm going to talk to you today about a tool that I wrote and a technique of pivoting from Windows to Linux or Unix machines in a penetration test. So we are going to see where the idea came from, which are the usage scenarios, the features of PuttyRider, technical details, and the demonstration for which I needed this exact laptop. A little bit about myself. I am a technical manager at KPMG Romania. I lead the penetration testers team, and I think we do a pretty good job at hacking local companies, banks, and other high-profile targets. I have some certifications, and I also did some talks at some conferences. We are also hiring, so we are looking for 2 penetration testers. If anyone is interested, just let us know. Okay, so how come this idea? This started from an internal penetration test that we did at a company in Romania. For those of you who don't know, internal penetration testing means that you, as a penetration tester, act as an internal attacker, and you have access to a network port of the internal company, of the internal network of the company, and you have some targets. For instance, the client company asks you if you, as an attacker, are able to gain access to the database of its most important clients, just starting from a network port. And we usually reached these targets. From my personal opinion, it was easier on Windows environments than in Linux environments. This is mainly because of the trust relationship between machines that are embedded in the Windows environment. And yeah, gaining domain administrator, it usually was pretty straightforward. We did it. But in this case, the target was actually a Linux server, which did not have any obvious vulnerabilities, and we did not find a way to directly attack it. Even though we had domain administrator account, we could not use it to log in to that target server, where the important data was located. Okay, so how to gain access to the data and reach the target? The answer that we came was to target the system administrators. We know that these are the persons who have the keys to the kingdom. Yeah? They have all the passwords, they have all the access, and if you have their rights, you actually can go to any server you like. So having domain administrator account, we used it to log in to one of the system administrators in the local network. And we did a screenshot. You know probably that with Metasploit, gain an interpreter shell, and you have the possibility to do PS, to see the list of processes, and you also can do a screenshot to see what the user is actually doing at that moment. And we saw that that system administrator had a PuTTY console open. And that IP addresses was one of our target servers. So at this point, we considered ourselves to be closer to our target, but we could not actually reach it. Let me ask you first, how would you do it? I mean, if you had remote access to a workstation of a user who may be logged on his workstation at that moment, you can access it remotely. And how would you do to take advantage of the fact that that machine has already a connection open to your target server? Hmm? Session, what kind of session hijacking? Which session? Do you know how to do that?
You can access memory. This session is stored somewhere.
If you're referring to session authentication information, that is not always stored on the machine. I mean, the admin can enter a password manually, so you do not have authentication information.
You can kill the session and force the admin to log in again. And with a keylogger, the password, you can use a keylogger.
Yeah. That's a good one. They said that you could install a keylogger and kill the PuTTY session and make the administrator log in again. That's a valid point, but it's pretty destructive, and we do not like to do that. And furthermore, we found situations where there were PuTTY sessions open on the machine for days or for a week because the administrator wants to instantly have access to its server when something happens, and they leave PuTTY sessions open. Yes, that was the situation that we actually used in this case, because I did not have PuttyRider at the moment. The particular administrator used a pair of public-private keys to authenticate to the server, and we found the files containing those keys, and we copied them from that machine to our machine and authenticated to the server. But we were lucky. Yeah. Yeah, but you actually cannot type yourself in that console. No, not necessarily, because it has the keep alive mechanism. It depends how it's configured, but not always. Okay, yeah. So in this particular case, we managed to gain access by copying the public-private key and gaining access to the Linux server. But we noticed that something was missing. Yeah. So the actual picture is, this is the attacker, was me. I connected with Metasploit to a process on the sysadmin's machine. And from that machine, there was another process which was connected to the target server. Okay, introducing PuttyRider. Do you know where the picture comes from? There was a movie, Ghost Rider, at the point. Yeah. It had some cool special effects, and I liked the picture. Yeah. So this PuttyRider tool actually takes advantage of the existing PuTTY connection in order to, first of all, sniff all communication between the administrator and the server if there is some communication happening. Passwords included also. Also, you can inject commands in the existing PuTTY session and be transparent to the victim user. So we do not want the victim to see that we are there. And also, I would like it to be interactive via remote shell. Yeah, and because we take advantage of PuTTY, we know that PuTTY can connect with multiple protocols, SSH, telnet, rlogin. So this tool actually works for all these protocols. Yeah, so PuttyRider will sit in the middle. So it will make the connection between the attacker via the sysadmin to the target server. Okay, remember please the colors. So the attacker is white, the sysadmin is blue. Yeah, we will have some more details afterwards. And when you see white, we refer to the attacker machine. When you see blue, we refer to the sysadmin's machine. So what it can do, it can list the existing Putty processes, inject a DLL into a certain Putty process, wait in background for new Putty processes to appear. It can automatically execute a shell command after injection, eject. And maybe you're wondering how will you extract the actual data, because PuttyRider will run on the administrator's machine. It has two output modes. It can write all the conversation to a local file on the administrator's machine. And another output mode is to initiate a reverse connection to the attacker's machine and start an interactive session via the existing Putty connection. I tried first to search to see if there is actually existing such a tool, because I wanted to use it at that moment. I found just this proof of concept. It's called Putty Hijack. It was written by a guy named Brett Moore in 2008. And as the author says, it's just a proof of concept. And it works only for Putty version 0.60, which was released in 2007. And if you try to run it on other Putty versions, it just crashes the process. And it has several drawbacks. So I thought, why wouldn't I start from this proof of concept and build a reliable tool that can be actually used in real-life penetration testing. So this is the way PuttyRider came out. It's written on C, on Windows, and uses Win32 API. And actually works on all recent versions of Putty. And furthermore, does not require administrative privileges. So if you gain access to an administrator's machine with his own credentials, and he is not local administrator, PuttyRider still works, because it injects into a process started by the same user. This is the architecture of the tool. Okay, so white, attacker, blue, sysadmin. The flow is the following. The attacker, using a remote shell on this machine, starts the PuttyRider.exe. This is the injector. And this injector executable actually injects the DLL into the memory of Putty.exe process. Okay? And after injection, it installs hooks on two functions from inside the Putty.exe memory. It's called ldisk send and term data. We will see what are those. And the communication, so PuttyRider DLL, after it installs successfully on the Putty.exe memory, it communicates with via a pipe with PuttyRider.exe, which transmits back data to the remote shell. This is one way of communication, but actually PuttyRider does not necessarily have to be here, .exe. This can be used only to inject the DLL, then to exit, and then the sysadmin will not see anything if he tries to do a process list, because there is actually only the DLL in the memory of Putty.exe. So there is no other process. And PuttyRider DLL actually can initiate this reverse connection to the attacker's machine, and the attacker must listen with netcat and at this moment to receive the traffic. Okay, I told you about those functions. So the main thing of PuttyRider is that it installs hooks on these two functions in order to hijack them. These two functions are ldisk_send and term data. These are functions from the source code of Putty. And the first one handles the input received from the user. So when you type at the keyboard, the characters that you type will pass through this function and then will be sent to the backend. And when the answer comes back from the server, it will come through the second function, term data, which will display the output in the terminal. Okay? And if you see the definitions of these functions, you can see two parameters. It's a buffer and a length, and also a data and a length. This is actually our data that we're interested in. One challenge for writing this tool was how to find the address of these functions, these two functions in the Putty memory. Because Putty.exe does not export any function, and we cannot use load library and get the process address to actually get the address of the function. The solution that I came up with was to download all the binaries of existing Putty versions. And then I managed to create signatures, binary signatures, for the two functions, for the beginning of the two functions. So for ldisk_send, I found 21 bytes. And if I search the memory of Putty.exe for these 21 bytes, I find uniquely this function, the beginning of this function. Then for term data, I found 3 signatures of 18 bytes, which cover Putties from 0.54 to 0.63, which is the latest version. So actually, by searching the memory of Putty.exe for these signatures, I managed to find the beginning of these functions. Then I have to do function hooking in order to hijack the functions. Function hooking happens as following. Here is the DLL main function, which is called when the DLL is loaded into the memory of a process. And we have this switch when DLL process attach. I call a start function, which does the following. Locates the addresses of ldisk_send and term data, as we saw previously. We also define 2 other functions, the handlers, my ldisk_send and my term data. And I actually overwrite into the memory of Putty.exe at the beginning of the legitimate function ldisk_send opcodes for the instruction jump to the address of my handler functions. So I have defined a separate function that handles actually the data of one of ldisk_send, let's say. And I override the beginning of the legitimate function with a jump instruction to my handler function. So when Putty.exe will try to execute its legitimate function, the execution will actually jump to my function. Okay? And here is how it happens. In the first column, it's a piece of memory of Putty.exe, and in the second column is the DLL loaded into the same address space of Putty.exe. This is the piece of legitimate function terminal data, and with red, it's the attacker's code. I mean my code injected into that process. So this is with the red here is actually the jump that I told you previously. So the putty code comes here. Then because of the jump, it will jump to my function, my handler. Okay? Then my handler will restore the legitimate function code, will modify the return address of the legitimate function, and it will do something with the data. Actually, the data will send it to the attacker or put it in a file or do something with it. Okay? And then call the original function again to do its thing. So in order for the user not to see anything. And then after the original function finishes, because of the modified jump address, it will also jump into another piece of my code, which reinserts the hook at the beginning of term data. And after that, the code continues with the legitimate putty code. OK. I think I talked too much. And we will see how it works. You know how they say when you do a live demo, you always have to pray that the demo gods are with you. So let's pray. OK. So we have this scenario. So the attacker is white, the sysadmin is blue, and the target server is dark. And yeah. OK. So this is the attacker. This is the blue one, should be, yeah. And the victim should be here. It's a Linux machine. This is the IP address of the target. So we want actually to reach here. And this is the system administrator, which runs putty, which should open. Here it is. So let's say that the system administrator wants to log into one of the production servers called ibank-prod. This is the IP address. It's actually that the other virtual machine. OK, so now let's say the system administrator is here. And he has this, this putty connection open. We will leave it always on top in order to see what happens. Now, me as an attacker, I will run metasploit. OK. OK, you should let it start for a few seconds. I opened the second terminal, and in order to simulate my access rights, I said that in my scenario, I gained domain admin account. In this scenario, I suppose that I have the hashes of the administrator account of the machine. Yeah. I also found a lot of times in practice where internal companies, so companies on their internal network, use the same password for a single administrative account for all the machines, local account. Yeah. So if you manage to gain access to one machine, extract the hashes of that administrative account, then you can use the hashes to gain access to other machines. This is actually a realistic scenario. Desktop. Okay, so this is the hash of the administrator. We will use the pcexec module. Show options. And first of all, we will have to set the remote host, which we can find it in other ways, but this is easier. So it's 129. Okay, we have a share. We need a share. In this particular case, it's called shared payload Windows interpreter reverse TCP. Show options, set AL host. This is the local host where we will receive the interpreter connection, 9.1. And we have to tell the SMB user and password. Okay, and this should work. Okay, so I gained access to the administrator's machine with Meterpreter. Right now we are system, but we are not interested in this role. We want to migrate into a process started by the same user as putty.exe. So I'm looking for explorer.exe. This is the process ID. And we will migrate into this process ID. Okay. My particular local user is called systems, yeah? So I am running code with his privileges right now. Okay, so let's go back to PuttyRider. So me as an attacker, I need these two files, PuttyRider.exe and PuttyRider.dll. And first of all, I need to upload these two files to the remote machine and then execute them. Actually, I did some tests previously, and I think they are already uploaded. So we are running in c/temp/PuttyRider on the remote machine. Okay, and right now we need a shell. And right now we're executing commands on the remote machine, right? Good. So let's see. PuttyRider. So we have a help menu. And these are the operation modes: list, inject and wait in background, use a certain PID, exec commands, and output modes. Okay, for the beginning, -cell. This is injected because I forgot PuttyRider running, I guess. Task list. Yes. I should kill it in order to start fresh. Okay, it is killed. It doesn't work. Yeah. So this is the situation, yeah? And the administrator has the PuttyRider console open, and with -L, we can see that there is a Putty open, and the connection is between our IP address and the remote IP address, and it's not injected with PuttyRider yet. And we want to inject it, and at the moment in this directory there are only these two files, and PuttyRider -p0. This means inject in the first Putty process that you find. And -f means that log all the session information in a local file. Okay, so what it does? Searching for a Putty process, it found the Putty with process ID. And when you see these messages with the process ID, these are received from the DLL. And the DLL wants first to find the addresses of ldisk send and term data by searching the address space of putty.exe, respectively the text section. Okay, and it found the target functions, it installed the hooks, and it created a log file at this location. And then the injector exits. And if we do dir, we see that the log file is created here, but it has 0 bytes. And now let's say that the administrator wants to do something. Maybe wants to change his password to something. Okay, so these are actions performed by the administrator. Right now, the Putty log is still 0 because it uses output buffering. And in order to actually get the output, we have to extract PuttyRider. So with -6, you actually extract the DLL from the Putty process. And now it flushed the buffer and it wrote the file. And if we look inside, what do you see? So it starts from here. It sees the local endpoint, the remote endpoint of the connection. And you can actually see what the administrator typed, including the clear text passwords. Okay, so this was the first scenario where the Putty connection was already open. Let's close it. And right now we're supposing that we gain access to an administrator's machine, and he doesn't have a Putty open, but we know that he will open it at some time because he's the administrator. And we want to leave PuttyRider running in background in order to listen for opening putty.exe. For this, we use the -wait option, and furthermore, when the Putty will open, Putty session will open, we want the DLL to initiate a reverse connection to our machine. And for this, we use this argument, 68.9.1, let's say on port 8080, and we have to open this port. We do it with netcat. So netcat is listening, and when the administrator will open the PuTTY session, we also receive here a connection from the DLL. Okay, we start PuttyRider. It's running in background now. The drawback here is that the administrator could see it in the list of processes, but you can rename it with a different name, update.txt or something. And right now, let's suppose the administrator opens a new session, not that one. So right now, the DLL has connected to our listener, and okay, so everything thank you. Everything the administrator writes here, it appears on our machine. But there is more. We can actually inject commands. In order to do that, we move to this tab. So if we try to send something, it tells us that you must first disconnect the PuTTY window, because otherwise anything that you will write here will appear to the administrator's window. And we don't want to do that. And we have also a menu here. And we can see the status. So the PuTTY window is connected, and it receives user input. In order for us to step inside, we have to discon. PuTTY window disconnected. And right now, you see, the administrator doesn't see anything. But furthermore, it cannot type anything. So we can do and the admin cannot see anything in the interface. And when we are over with it, we can do a reconnect. And right now, the admin can do its stuff. Yeah, and if this session closes, we can see that our connection is closed. And when the administrator opens again, we can see, again, client connected with another process ID. Yeah, so PuttyRider will be available for download in a few days on GitHub, because the latest changes, I did them last night. But I promise you, in a few days, it will be available for download freely and to be used for your purposes. Thank you, and if you have other questions.